Alright, in this video I want to talk about significant figures. And significant figures are probably easily one of the easiest, simplest points that are missed on a chemistry test. And the rules are relatively easy and simple. I'm just going to go over them now, and that way you'll never have to miss points on any of your chemistry exams or quizzes. You'll know them for the rest of your life. And there's just a few simple rules to significant figures. Let's kind of go over them now. The first one are all non-zeros are significant. So, for instance, 1.5 here, neither one of those are 0, so that has two significant figures, right? So anything that is not a 0 is significant. The next one are interior zeros are significant. So are significant. So for instance, 1.05 would have three significant figures. The 1 would be significant, the 0 would be significant, and the 5 would be significant. So that would have three significant figures. Next rule are leading zeros are not significant. Are not significant. So, for instance, we were to take 1050. This would have four significant figures. 1, 2, 3, 4. These would not be significant because they are leading, what's called leading to the number, leading zeros, and they are not significant. You may say, well, wait a second, Justin, you said zeros between two numbers are significant, and leading zeros are not. What's with this guy right here? He's not in between two numbers, and he's not leading. Well, this leads me kind of to the next one, in trailing, next rule, which are trailing zeros. Let me switch colors for this. Trailing zeros are significant, or after, I guess I should really clarify, after a decimal point are significant. So in the case of, this number right here, this comes after the decimal point, so it is significant. But let's look at another one even. Say we've got 1050. A lot of students are tempted to say, well, this has three significant figures. 1, 2, 3. But it really, in reality, has four significant figures. This 0 is significant because it's after a decimal point. It's a trailing 0 after a decimal point. This is not true in the fact of, say, 1000. These are trailing zeros, but they are not significant. So 1000 has only one significant figure, and 1.050 has four significant figures. So a lot of easy mistakes that seem to be made there. Try not to make them yourself. Let's talk just a second before we get into addition and subtraction and division rules about scientific notation. All right, scientific notation is only the numbers present, like let's say 1.25 times 10 to the 23. Those 23 zeros that are following or decimal points being moved from the 1 after the 1, those are not significant. None of those zeros are significant. In the case of scientific notation, only the numbers present are the ones that you consider being significant. So this would have three significant figures. All right, let's take and do some division and subtraction rules. Let's say we've got we'll do division and subtraction first. Let's say we've got 2.00 times 3, all right, equals what? How many significant figures does our answer have to have? Well, the basic rule for this is you add up all the significant figures, you add them all up, you write it, you add all the significant figures, and your answer is going to have the same amount of significant figures as the lowest significant figure in your problem does. So this has 3 significant figures. This has 1. So our answer is going to have 1 significant figure. Put an SF there. 1 significant figure. So we would write it like this, just 6. That's 1 significant figure. Let's do a division problem. Let's say we've got 2 divided by 6, right? How many equals what? How many significant figures is our answer going to have? Or actually, let me spice it up here a little bit even. Let's say we've got 2.000 divided by 6.0. All right, we're getting real crazy now. All right, so how many significant figures is our answer going to have? Well, this has 1, 2, 3, 4 significant figures, and this has 1, 2. So our answer is going to have 2 significant figures. So we would write this as 3.0 to show 3 significant figures. That's about as crazy as it, and hectic as it gets with division and subtraction. It's pretty easy. Let's move on to something that's a little bit more difficult. So let's take, for example, addition and subtraction. This is a little bit harder to do. So let me switch colors here. And the majority, I would say probably 99% of what all students miss on significant figures are addition and subtraction, because the rules are a little bit different than they are with division and subtraction. So let's say 2.345, and let's say we're adding 0.7, and let's say we're also adding 2.9975. Okay, so let's do this. Okay, basically the rule with addition and subtraction is that you go with the lowest significant figure number that you're adding. So in this case, or I guess lowest significant figure number, you do it. You only use the significant figures that are to the lowest decimal point. I hope that's not too confusing, but basically you line them up like this, and you look at it and you say, well, 0.7 only goes to the hundredths place on the decimal point, so my answer can only go to the hundredths place on the decimal point. So what we're going to do is add these up, and it would be 5.4125 looks right. Yeah, 5.4125 would be our answer here. And we're only going to include our answer to 3 significant figures because this is 5.41 to the lowest decimal point. That's the amount of significant figures. Now, let's point something out here. Rounding, right? Let's say if this wasn't a 2. Let's just pretend for a second, for some reason, that this would have been like a 9, right? We would round this 1 to a 2, and we would say it's 5.42 instead of 5.41. Now let's just pretend for again a second here. Let's say this was a 4, right? Let's say this was a 4. We would not round this 5. We wouldn't say, well, this 5 will round this 4 to a 5, and then that 5 will round the 1 to a 2. You're not going to go that far. Just this number right here is as far as you're going to go on your rounding. So if that's 5 or greater, you're going to round this to the next number. That's addition, same thing with subtraction. If you were doing subtraction, you would draw this line, you would do it exactly like this as well. So let's get real crazy here, right? Let's say we've got 5.00 minus, I don't know, 1.99 divided by, or no, let's say times 2. All right, so we've got both addition and subtraction in our problem here. So how are we going to solve for this? And you know what? Let me even make it a little bit crazier. Let's say 5.1. Right? So 5.10 minus 1.99 times 2. How many significant figures are we going to have? Well, you would line 5.10 minus 1.99. You're going to draw your line there. We're only going to go to the tenths place on the decimal point. So that's going to end up being 3.11 by the time you're done, but we're only going to say 3.1. So let me write it over here where you can see it. So 3.1 times 2. Right? That's going to give us 6.2. But this right here only has one significant figure, right? We've got 2 significant figures in this problem and 1 there. So what are we going to do, right? Well, our final answer can only have one significant figure. So we're just going to round this 2 right here down to a 0 because it's not greater than 5. So our final answer is going to be 6. 6 is our final answer to one significant figure. That's about as tricky or as crazy really as you can get with significant figures. So anyway, I hope that wasn't too confusing. I'm going to attach a few worksheets on here for you guys to practice on as well.